All right, so now we're going to talk about the ratio test. All right, so it's just like it says on this thing here. The ratio test. If n plus 1 over n is less than 1, it converges absolutely, in fact, but we're not going to do absolute or conditional convergence. That's taken out this year. So it just converges. And if the ratio is greater than 1, it diverges. And if it equals 1, your test is useless. You got to use some other way. Okay? All right. So let's write that down. So let's see. Let L equal the limit as n goes to infinity of the absolute value of a n plus 1 over a n. If 1, L is less than 1, the series converges. L is greater than 1, and that also includes infinity, or infinity, it diverges. L equals 1, inconclusive, which means you need to use another test. It doesn't mean you can, the answer is not inconclusive, it just means sucks for you. Try again. Okay, so let's do an example. So the converge or diverge. Okay, 1. The sum from n equals 0 to infinity of 2 to the n over n factorial. Now, as you saw from that list you made, which I pulled Andre's up, and we're going to cross off 3, 4, 7, and 8 now because they have been removed from this test due to the COVID virus. So issues. Normally we would have all of these here, but we're just doing 1, 2, 5, and 6. So if you look at these and you go, okay, just do this at a glance. Does it go to 0? We've already found out that n factorial is way faster than anything else. So yes, the limit goes to 0. Next, is it a p series or geometric? That means is it raised to something, the whole thing raised to a p, or sorry, is it like a denominator raised to a p, to a number, or the whole thing raised to an exponent, like a number raised to an exponent? No, so it's not p series or geometric. Does it have a factorial? If the series has a factorial, you must use the ratio test. So whenever you see factorials, you're going to think ratio test. Okay? All right. So how do we do the ratio test? We go the limit as n goes to infinity of a n plus 1 over a n, absolute values. The absolute values are unnecessary here because it's not an alternating one, but if it were alternating, you could still use the ratio test, okay? All right, so we're going to say, well, that's the limit as n goes to infinity. Now we just plug it in. 2 to the n plus 1 over n plus 1 factorial over 2 to the n over n factorial. And that equals the limit as n goes to infinity of, okay, now this is going to happen a lot, so things are going to cancel. So we get 2 to the n times 2 over n plus 1 times n factorial. That's that top one. Times, now flip the bottom, n factorial over 2 to the n. Okay, see, that's 2 to the n, 2. N plus 1 factorial is n plus 1 times n minus 1, blah, blah, blah. Or in other words, just take one off and then start with your factorial of the next one. So n plus 1, n factorial. That's going to be the common trick with all of these. Okay? And that equals the limit as n goes to infinity. Make sure you write the limit as n goes to infinity every time. Okay, now my n factorials cancel and my 2 to the n's cancel. So I just get 2 over n plus 1. Okay, and then what does that go to? Well, n is in the denominator and it's going to infinity in the bottom. So you get 0. And then we just look at our ratio test, which it's 0, so that's less than 1, which is in my convergence column. Okay, so then I say therefore, by the ratio test, the series converges. Pretty nice, huh? You can even say converges absolutely if you want to be fancy, because that's where we were headed before the COVID virus. Okay, so next one. The sum from n equals 0 to infinity of n squared, sorry, bad camera work, n squared, 2 to the n plus 1, sorry, my stuff is hard to read, over 3 to the n. Okay. This is let's see, what is that? Nothing. That's like a polynomial. So that'd be like an integral test right there, right? And then this is 2 to the n over 3 to the n. So I could say that's 2/3 to the n. Basically, you could take out that 2 outside of it, right? So 2/3 to the n, which is what's something to the n that is geometric. But you can't do a combination of integral test and a geometric. So my choices would be integral because geometric fails, or ratio. Really, ratio is my favorite. It just does that nice stuff all the time. So I kind of jump to it a lot, actually, even though it's down on the list. Okay, so let's try it. The first thing I always do is think about, does this go to 0? I honestly have no idea. 3 to the n is definitely faster than 2 to the n. And I'm guessing way out because exponentials grow so much faster, as we've seen with all the charts in the news, then what is this? This is a quadratic, so that's a parabola. Yeah, and then exponentials are like, boop, straight vertical lines. So I'm thinking it goes to 0. I can't really say otherwise. I would have to do L'Hopital's to do that. I'm just not gonna. Okay. That's what it says in that list even. It says don't spend a lot of time on this, though. Just look at it. If you can't tell, then just move on, okay? All right. The limit as n goes to infinity of n plus 1 squared, 2 to the n plus 1 over 3 to the n plus 1 over n squared, 2 to the n plus 1 over 3 to the n. And I like to put my parentheses so that my grader can tell what the heck I was doing. Okay, and that equals, all right, the limit as n goes to infinity of, well, that doesn't really simplify, so I'm just going to leave it n plus 1 squared times 2 squared times 2 to the n over 3 times 3 to the n times 3 to the n over n squared 2 times 2 to the n. Right? 2 times 2 to the n squared. Now on the bottom, 3 to the n, now on the top. Keep, change, flip, right? Okay, and then that equals, I don't know why I put a triple equals, it does not, although it is equivalent to, and that's what a triple equal bar means. Okay. What does that mean? Oh, that's for No, that's yeah, never mind. Okay, so now what cancels? So the 3 to the ends cancel, the 2 to the ends cancel. No, I'm not actually canceling them. All right, because it's just bad form. All right, so the limit as n goes to infinity. All right, so we end up with n plus 1 squared. One of the 2's cancels with one of those, so just a times a 2, right? 2 to the ends cancel. The 3 to the ends cancel. So that's everything there. Over 3. And then the n squared. That 2 canceled with that. And then 2 to the n. If you got to write on it and clip things out, that's okay. Okay. This is a 1-to-1 ratio. Well, the n squared over n squared. So it's a 2 to 3 ratio. So that equals 2/3. Which 2/3 is less than 1. So, therefore, by the ratio test, the series converges. Absolutely. Absolutely just means its absolute value converges. Okay. Let's see one. Sorry. Let me see if there are any other ones that are trickier or anything like that. No, that's pretty easy. If it comes out greater than 1, you get diverges. I'm not going to do one that comes out as the same. Yeah, no, I think that's good enough. I think just some practice is what it's going to take. So that's it.